Firstly, you need to calculate the apparent power, which is KVA. The formula for KVA is the square root of 3 multiplied by the voltage multiplied by the average amperage. In this case, the voltage is 480 volts and the amperage readings are 325 amps, 321 amps, and 330 amps. Adding these amperage readings together gives a total of 976 amps. Multiplying the square root of 3 by 480 volts by 976 amps gives you 469,280 volt amps. Secondly, calculate the real power, which is KW. Formula for KW is the power factor multiplied by the KVA. Since the power factor wasn't provided, let's assume a typical power factor for a generator of 0.8. Multiplying 0.8 by 469,280 volt amps gives you 375,424 watts. Thirdly, calculate the remaining capacity. To find the remaining KVA, subtract the measured KVA from the nameplate KVA. The nameplate KVA is 500,000 volt amps. 500,000 volt amps minus 469,280 volt amps equals 30,720 volt amps. To find the remaining KW, subtract the measured KW from the nameplate KW. The nameplate KW is 400,000 watts. 400,000 watts minus 375,424 watts equals 24,576 watts. Therefore, the generator has 30,720 volt amps and 24,576 watts of remaining capacity.